Hello, today I'll be showing you how to process static data using Compass solution software. Compass solution software is a static processing software by Comnav technology. It can also process PPK. So the first thing you have to do is to launch Compass solution. Run it as an administrator. You have to run it as an administrator. That's the first thing you have to do. Okay, so once it is open, you go to file, you create a new project. Now when you're creating a new project, it also gives you the opportunity to create a new coordinate system if necessary, if you've not created your coordinate system before. Also, you should also select your data path where you want to store your data. So for this one, we are using static tutorial folder in our documents folder. So very necessary to select your project path. Now under template, we are going to create a new template. So I click on modify, create. So give it a template name. Here we are using MENA 31 not. You click on datum, you add a datum, put in the coordinate system name for your datum. So we are using MENA and MENA 31, which uses Clark 1880 ellipsoid. Okay, so if you have 7 parameters transformation, your 7 parameter transformation, you can key it in here. If not, you just leave this place empty. Just leave this place like this. You go to projection. Our projection is UTM. Our zone is 31. And select joint model. The joint model here is EGM96. Select it. You can select any joint model you want. The one we have here is EGM96. So we have everything set up now. And you can just click OK. Then you go and select it and see it there. You say OK. So give you this message, doesn't matter, say OK. Time, you can use GPS time, you can use your local time, whatever you want. Click OK. And you can close this. Then you need to select your template that you just created. And select OK. OK again. Don't worry about this message, this is from my own system. Okay, so now you've created your project. It's good to save it. Give it a name. Next thing is you import your static data, your static raw data from your static observation, the data you downloaded from your differential GPS. So here, this is Comnav binary format. If it's Rhinex, you can also import Rhinex format here too. This one was recorded in Comnav binary format. Okay, so you can see all our observations. You click on observation, you can see all our data. So the next thing is to edit your station name and antenna height. So you can do that by right clicking on each one and editing each one. But you should have all your data for each station or your field book. So So all you have to do now is just to transfer that data to the software. Select right click on antenna height, you put the value that you measured, the antenna height that you measured on site, as from the center of the marker to the receiver. Depending on what you use, this one here now, the value is 1.63. If it is here, we are selecting notch of receiver, which is the edge. You see a mark on the edge of the receiver where you measure to using your tape. So if you use the bipod with a pole, 2-meter pole or whatever the height is, your measurement will be to bottom of receiver. Measurement will be to bottom of receiver, but in this case we used the tripod and measured from the center of the control mark to the edge of the receiver. Now receiver is M5, Comnav Gnss M5. So we'll do the same thing for the other stations. Put in your antenna height. Notch of receiver, select your receiver type. This is for the core station data. So after doing all that, you've edited your data. It's always good to save your work. Refresh. You can see now that we've not inputted the station names of each station, so we need to do that. File, go to the properties, file properties to edit and key in the station names. File properties, key the station name there. So you can also change the antenna height here, but in some versions of the compact solution that change button may not work. So you can do it under antenna edit as we did earlier. So this station is OTSB. This station is OTSA. Can see antenna button is not working on this particular version, but you can do it here, which we've done before. This is the core station data. So always good to save your work. You can see now all the station names are there now for the 3 stations. Save your work. Okay, so after you've imported your data, you've edited it, next thing is to process the baselines, static baselines. We have 3 baselines. We use 3 receivers, 2 M5 receivers and 1 and the core station. So under static baseline, you can set up the static baseline processing parameters. You have sampling interval, ref satellites, elevation marks. You need to your concern here is the sampling interval and also the elevation mask. Sampling interval You can set to 5 seconds or 10 seconds, depending. The longer amount of time you spend in your observation, the higher sampling interval you may use. Elevation marks to speak to the horizon, the angle of cutoff for satellites. Most times, if the area is open, you can use 10. If the area is not that open, you can use 13 or 15. If there are buildings around, if there are structures around, you can increase the elevation mark so that it will cut off satellites that are blocked by the structures around. Also, you can look at the troposphere and ionosphere. You don't need to make any changes there. Here, you set the software will use all the 4 constellations for processing. Now, for completion of observation, when you process, if you don't get good results, you can come here and choose another combination of observation and then process again and see and check your results. Okay, so for next thing is to process. Select, we click the process button, and the baseline processing has started. So if you see the first one, fix, that's processed. Second one, fix, that's processed. The third one, fix. So baseline processing is completed. So we want fixed solution for the best result. Also, we need to look at the key quality indicators like the RMS and the ratio and the RMS. It's best for the ratio to be above 3 and your RMS to be millimeter as low as possible. Sometimes you get centimeter, but just make sure that it's not high. The lower the better, but when you are doing long distance observations, it may be higher. This is a very short distance static observation for the purpose of this tutorial, so we have very low RMS. Most times you get RMS in centimeters. So our solution are all fixed. So after processing, you can now edit your data to remove bad data and also make an attempt to increase the ratio. So when you click on satellites at the bottom, you can see the satellite signals. You can see green from beginning to the end. That's good. This is good observation data. Where you have breaks, those breaks. Sometimes you need to delete those breaks. They are satellite obstructions, where there were obstructions to the satellite view. So make sure anytime you do static processing, you remove the bad data, all those breaks, all those partial data, you remove them. This data is, you can see this one. This satellite G22 is a GPS satellite. You can see the USA satellite icon by the side. It's a GPS satellite. You can see it didn't really work well. It didn't really provide much data. So we switched up that one completely by unchecking the satellite number. So most of the data, this is good data. This is really good data. You can see. So the C is for Beidou constellation, E is for Galileo constellation, R is for GLONASS constellation, and G is for GPS constellation. So we do this for each baseline. Switch off that satellite, there's no need. So after you process again to see if you have better results. Okay, so we're not able to improve the ratio for 2.5. Actually, so in this case, you may want to change the sampling interval. You may want to change the ratio and reprocess that baseline alone again in order to improve the ratio. So it's very minimal improvement, from 2.5 to 2.6. You can try 10 seconds. Come back to 2.5. So we will not worry about that because we have a very good RMS. So we can also change the elevation mask and try again. So this is how you process and get best results. You change these things depending on your observation. You look at your environment. If it makes sense to increase the elevation max, increase it. If it makes sense to increase the observation time, increase it, and you process that baseline alone again. But you do this after you've removed the bad data on the satellite tab at the bottom. So since we have a low RMS, we can go ahead to from static baseline processing to adjustment. So take note of the process of the steps from importing to editing observation data to static baseline processing now to adjustment. So first thing, we look at the adjustment parameters. If you are using WGS84 geographic coordinates, you use 3D. But if you are not adjusting on the WGS84 datum geographic coordinates, you use 2D and height fitting. 2D for X and Y, height fitting for your height for Z. Next thing is to specify the control. Is to tell the software what control you want to use for your adjustment. So our control is the course. We select XYZ and make sure that the constraint button is selected. Then we key in the values of the value of the control. So key in the value and click OK. Then we can run our adjustments. So run our adjustment. You can see our fixed point before station. So you can see the other ones unknown or unsolved. But when you click OK, when you run and you see solved, so you can see our coordinates. So we go to adjustment report to see our adjustment report at the bottom. Double click it, launch your adjustment report in the browser. Okay, so this is our results. You can see our baselines and everything. Look at our coordinates. You can see under 2D coordinates, you can see our coordinates there. Coordinates for OTS-A, coordinates for OTS-B, and then the heights at the bottom. So That's how to process static data using Compass solution software. So you can copy these results into a Microsoft Word if you want.